Oh, okay, hello. This is the Unit 8 test corrections. So, okay, first question. Here. On the dot, which represents the sphere, draw and label the forces that are exerted on the sphere just after its release from rest. Each force must be represented by a distinct arrow. So, here I just drew FB, the point force going up, and then FG, the gravitational force going down, and then that is the right answer. So, say level force is larger. Yep, that's what I did. 3 out of 3. And then part B, starting with Newton's second law, deriving an expression for the height of the sphere above the bottom of the pool as a function of time after time t. Before the sphere reaches the top of the water, expresses your answer in terms of those things, and then okay, so um, I don't, I don't know what happened here. I don't even know how to do it at all. So I was just, I think I was just writing a bunch of gibberish, but I got it. Pretty sure I got it completely wrong. I can't zoom in. So what they got y equals that, and then I got h, well, the height. So it's the same thing equals that. I don't even know what I did here. Wait, PVG equals MA. So I got up to minus mg, so that's right. A equals, oh, okay, so it did what I got up to this part, or no, I got to this part, but for some reason I changed the MA to MV over T, and then I didn't isolate the A like I was supposed to do here, so I could plug it in to to this equation. Y, well, it would be x final equals x initial plus v02 plus 1 half at squared, and then instead I don't I just started isolating like a bunch of random stuff, and I didn't even know where I got my h. So that's where I messed up. Like I just didn't know to get to here to isolate for acceleration, and then plug it in to that position equation. So what I should have done was keep this as a, like do all this and then do a's, arm a is equal to, okay, I'm just gonna type this. So ma is equal to um mg, okay, oh my god, mg plus p's pw, uh 4 over 3 pi r cubed. What is that? Pi over cube times g equals to ma. Oh yeah, equals ma. And then isolate for a, so you have a equals um, mg plus pw 4 over 3 pi r cubed g. This is supposed to be a g, right? No, that's not supposed to be a g. And that's all wrong. And then this is all over m. And then you get the position equation, which is the final. So I guess you go y because it's vertical. So yf is equal to the initial. Alright, like the initial because 0 because what's the question? Yeah, so this is 0, b0, b0 is also 0, and it cancels out the t there. So then you have 1/2 a, but then a is just this, so I'm just gonna grab this. So this, and then over 2, and then it's t squared. T squared right here. T squared. So now you have y equals, y final is equal to this. And then MRPWT. So MRPW and then T. Oh, okay, that's it. Right. 1/2 M. Wait a minute. Oh wait. Mine is G. Oh yeah. Yeah, because this G, the M cancel. Okay, yeah. So this is where, and I messed up right here because I didn't know that was supposed to isolate for A. So that means I just got this one wrong. Wait, but one is for a multi-step derivation that begins with Newton's second law. I did begin with Newton's second law. Right here, F equals ma. For including both the buoyant force and the gravitational force, I did do that. Fb minus Fg, I did do that. 1 point is earned for using kinematics to relate acceleration and height above the bottom. I didn't do that, and then I didn't get that. Okay, so I got 2 out of 4 for this one. So 2, oh, what the, whatever. Okay, next. C. The pressure exerted by the water on the sphere at the bottom of the pool is P0. On the following grid, sketch the pressure exerted on the water by on the sphere by the water section at time t before it's reduced. So here I got it goes down, and then the answer is it goes down. Concave down goes down. So vertical intercept of P0. Yep, vertical intercept of P0. Sketch that decreases from the initial value. Yep. And then for sketch that's concave down. And I did that, so 3 out of 3. Okay, part D. Sphere takes time t to travel. What the hell? Sphere A takes time t to travel from the bottom of the pool of water to just below the surface of the water. Sphere B, which has the same radius as sphere A, but mass 2m, is released from rest at the bottom of the same pool of water. Justify why the time sphere B takes to travel from the ocean, from the bottom of the pool just to below the surface of the water is greater than t1. So if it's greater than t1, so here I put, since sphere B is 2m, the Fg is greater, which means that the net force of the sphere is smaller because the Fg acts against Fb. And you know, since it's going up, Fb is the force of the buoyancy force is bigger than Fg, but Fg is a little bit bigger than it was before, so that's why it goes slower. Since the force is smaller, the sphere will take longer to travel. They said, okay. 1 point is earned for the justification of attempts to use functional dependence to explain all the time for sphere B is greater than sphere. Okay. Statement is buoyancy force on the two spheres is the same. Did I say that? Nope. Force statement will be larger. Force of gravity exerted on sphere B will be larger than the force of gravity exerted on sphere A. Yep, that's what I said. So I got that point. And then includes one of the following: smaller net force of sphere B means smaller acceleration. The net force is smaller. Yep, I said that. Since the force is smaller, anyway, that is small acceleration. I didn't really specify the second part, so I guess I only got 1 point. I kind of just jumped to the force, making it slower. So I got 1 out of 2. So total score 1, 2, 3, 4, 5, 8, 9 out of 3 points missing. So 9 out of 12. Okay, thank you.